I'm going to share my screen now. Okay, so the first thing I want to go over today is I want to answer a question that was asked at the end of last session, and the question was, how do you create a best fit profile? And I believe that was from Sheetal, so she can. I guess when she watches the recording, then she'll be able to see this. So if I come into this horizontal alignment and look at the profile by clicking and hovering and opening the profile model, it's already here. So so now we're in the profile model, and we're going to be using a command that is in the vertical geometry tab, and it's called define profiles by best fit. And so if we click on this command and we look at the prompt and to see what information the computer needs to input, we have these values here, and they're usually set to all 0, and then you can change these to whatever suits your project. So what this is asking for the upper envelope is how high from your existing ground, how high do you want your best fit profile to be? And so you can input whatever dimension in feet that this will that fits your project. So I'm just gonna do 3. So the upper envelope is how much it'll go above, and lower envelope is how much it'll go below. And then we just have these curve length parameters that you input. So we can just give it arbitrary values for now. I'll say for crest, let's do 700, and sag, I'll do 500. Then you can give it a minimum curve length and just say 250. So once we have these values inputted, we can pick our element template and give it a name. Then we'll click through the command, and this is locate profile to fit. So we'll click on it. Then you see the envelope that we chose there. Lower than our curve lengths. So then we click through here, and then here is where we have our best fit profile now, with the values that we gave it, that we gave the software. So I think this is a pretty cool feature that you can use. And what's even more cool is, well, you can change these parameters. So if anything, if you don't like the way you input it at the beginning, then you can just change these values, and all you need to do is click and then go to properties, and then you can change these values here. And what's even better is we can actually export this alignment to the GPK, and if you see, if we click on the alignment and we go to this paperclip, then it'll give us all the information for this best fit profile that we just created. It gives you the PVCs, the PIs, PTs, the K values, the links, and everything. So I think it's pretty cool. Honestly, I've never used this command, but I'm sure there'll be times in the future where I'll need to use this, so I can get a quick profile. And obviously, I'm pretty sure this is a bridge over here, so we would need to connect that somehow and get rid of these. Yeah, so I think that's how you create a best fit profile. Maybe I should ask, now that we're done with answering that question, if there are any more questions from the last session that I can maybe answer before we go into our topic for today. If not, then we can just
get those.
Was
Anybody
that?
else?
Okay. Okay, we
No, I
can
guess
continue.
not. Trey.
Yeah. I'm good. Okay, so why don't I actually, let me see. So the topic of this session is going to be creating the templates for our corridor, right? And what this means is we're basically going to create our typical section here. So this is exactly how our template is going to look, and then all we need to do is apply our template to our geometry, and we went over how to create the horizontal and vertical geometry in previous sessions. So I think I'm going to actually use this best fit profile just for our vertical for now. So we do need to make sure that when we are making corridors and applying templates to our geometry, that our horizontal geometry does have an active profile. And if you can see here, it says US67, and it has an active profile, which is the best fit that we just created. And let me just change the feature definition. Okay, so now we're going to go into the corridor modeling tab, and we are going to select create template, and this is where your templates are stored. So for what we're doing, I'm going to create a new library, a new template library, and you can just put it here. Maybe like. So now we have our blank template library, and what I'm going to do is now I'm going to create a template, and now here's the main interface that you're going to see when you're creating these templates. So I'm going to, we'll just say 67 here for template 67. And I'm actually going to get close, and it's going to ask me if I want to say this, and I'll say yes. So just to reiterate, we went to corridor modeling, and we went to create template, and this is where our library is. This is where our library is. So this is where all our templates are, and the templates that we need for whenever we're applying applying the template to the horizontal and vertical geometry. So now, if you right-click and if you just right-click, then you say there's this dialog for add new components, and here there's several component types that you can choose from. So there's simple, to where it'll do some kind of simple, it'll add a simple, like a block, I guess, and then I mainly use the constrained component type, and what this does is, if you click on it, then we can left click and keep left clicking whenever you wherever you want your points to be, and then we can make whatever shape that we need for whatever element we're trying to make in 3D, right? So if I were to apply this template to our horizontal and vertical geometry, this is what it would be. This is what it would look like. Just probably not what you're going to want to be doing, but so this is the main. So I like to use constrained, and you can even use unconstrained too. And I guess maybe this is a good point to show you what this color means, because the color of the crosshairs for the points. So I don't know if you noticed, but when I did a constrained component, the first point that I picked, it was green, and then all the points after that are red. So what this means is, if I double click on this point, then it gives me a dialog box. And what the red means is that this point is constrained. It has two constraints. That's what that means. So if I were to, and here's another really important dialog box that you're going to see when you're working with this template libraries, if you're creating the templates. So here's the name that you're going to give the point, and here's the feature definition that you're going to give the point. And this is really important, the feature definition, because if you want to be able to annotate the cross sections, then there has to be, this needs to have a feature definition. If it doesn't, then you won't be able to annotate it. So it's really important to know what happens when you don't have a feature definition on there. And there's a super elevation flag, what they call, and we can go into more about what this means as we continue through this session, and we can talk about the alternate surface later as well. But basically what this does, alternate surface, quickly, is this is how you're going to create your proposed terrain, and we'll definitely go over that. So to get back to the constraints, right, this point, hinge 6, right, hinge 6 is horizontally constrained and vertically constrained to this hinge 5. And we can say that we don't want it to be constrained anymore horizontally, and then if we hit apply, then you see that it goes to yellow. And these are the three main point constraint characteristics that you'll see. You're either going to see green, yellow, or red. So green is no constraints, yellow is one constraint, and red is two constraints. So it's really important to know what these mean and how to use them. Right, and just to a little run through about what type of constraints or which type of constraints you can use. If you click on the type, then you see that you have these classifications that you can use. And I normally use horizontal, vertical, slope, and vector offset, and we can go through how to use these. I don't usually use these, but I'm sure there's I'm sure they can be useful. I just haven't had the opportunity to use them yet. But I think these first four can pretty much help you create whatever you need for your typical section. So here's let's look at modifying some constraints and see kind of how these work. So if you notice, there's this little crosshair for right next to the name, and then there's a crosshair right next to the parent, is what they call, which is what this point is constrained to, right? So if we click the crosshair up top, if we click on it and we click on another point, then it'll give me the dialog for that point. And this is really useful, I've found, because you would need to exit, then double click to get up another dialog box for another point. So this is pretty helpful when trying to navigate to a specific point that you want. And you can also do the previous or next point, and it'll kind of click through those. So let's go to this rhinge 6, and then we'll see what happens when I change the constraints. So let's say I want this rhinge 6 to be, let's say I want it to be a slope from this point, rhinge 3, and this is the other crosshair that you can use, and this is to where you can pick which constraint parent do you want this point to be. And in this case, I'll just make this hinge 3 our constraint, or our parent, and then can change this value here. Let's say I want to be at -2%. Okay, let's change. So yes, sometimes this will happen. And one way to fix this is you can either change the sign and it should fix it, or if we add another constraint, if we add a horizontal constraint to this same rhinge 3, then we can say, I want you to go 8 feet out. And then we can change this back to negative, and then you see how it slopes depending on the whichever value, and the sign does matter. So, but if I were to change this to -8, then you see that it makes this point higher than the R-hinge3 because we're multiplying a negative and negative, so it goes positive. It goes higher than our hinge 3. So if we were to change this, then because we're going negative, then that's kind of, or that's why you would need to change the sign. It can be confusing, but as long as you use it and you know how it works, then I don't think you should have that much trouble figuring out what which sign needs to be where. So now what I'm going to do, since we kind of went through, okay, actually let me talk about the components as well. So if you click on the shape, then you get the component properties, and then if you click on a point, then you get point properties. So this component properties, if it has a certain feature definition on it, then it will change the symbology. And this is also important to have the correct symbology, because, or the correct feature definition for whatever shape is on your typical section, because we can get quantities from our corridor, and this is how the software will know how much quantity of this, of whatever shape on whatever feature definition. That's how the software knows, and it's also how the software knows the difference between cut and fill when you're doing earthwork. So now that we I feel like I've gone through the main points of this interface, and there's also one little hidden thing right here. This is the dynamic settings right here in the bottom left. So if you click this, and if you notice that here's my default point name, and that's why all the names that I used were called hinge. And the reason they have R and L is because I have this apply affixes on. So if I turn this off and I try to create another element, then you see that there's no, it does keep the name, but it doesn't give me whether it's on the right or left. So we can change this if you want. Let's say center line or whatever. And then we can. So it's good to know about this. And then if you, I believe if you choose the feature definition from here, then we should be able to see that this was the feature definition that that was the default, and that's what they gave here. But for these for these points that I created on this side, I didn't have my dynamic settings up, so I think that's the reason why it didn't give it a feature definition. So just be aware of that. There's a lot of things that you need to know that are happening when you're working with these. And to change your affixes, you can go to Tools and Options, and then you can change this information here if you wanted or needed to. So now I think we've covered mostly everything about the main topics about points and components. So now I think I'm gonna create the typical section for this project, and then we can go ahead and apply that to our corridor, and we can see it in 3D. So another cool thing is if you wanted to delete some components that you had previously drawn, but you don't want them anymore, once you hit delete components by right-clicking, so you right-click, delete components, and then you can click and drag with your left click, and then it'll delete those components for you. It's pretty nice. So that's a pretty useful thing that I use pretty much every time I'm in a template library. So we can go ahead and create our typical section now. And here's what it looks like. So it looks like we'll need to create a center line point here where the profile is being controlled, or the PGL. This is the PGL here, and then we're actually not going to start. We're not going to start creating the template until here, because this is the only proposed work that we're doing. So this is a pretty simple section. So we can go through this right now. And so I'm going to start by adding a component, and I'm actually going to create a point this time, because I want my center line point. I want all of my template to be referencing the center line point. So I'll keep this at center line, and we can change this point style to geometry center line, or whatever you prefer. So I'm gonna make this at the 0, 0, and you can see that my cursor has the coordinates up here in X and Y. So if I come here, and this can also be useful too, the step. This is how much if you see, I don't know how to explain it, but how much, like, I guess the grid line that you want to use. So this is at 1/2 foot right now. So if you see, it goes from 3 to 1/2 and then to 4. So you can change this if you need to. Let's see. This step is for the X, and this bottom step is for the Y. So then I'll come here and just choose this, and now we can get started. So I'll just create I'm going to do a unconstrained, and then we can go through all the points and define them the way we want to. So I'm going to click on the unconstrained, and then we can say, what do we want this to be called? So we'll just, we can always change these point names later, so I'll just make it hinge, just what it was. And then we can, I'll kind of make the shape, and then we can focus on the constraints after that. So I'll go somewhere close to where it's actually going to be, so we'll go like 12, and then I'll click, and then we can, here is where you would pick your component, right? So you see how my component is orange right now, but we can change it, and it'll change its features. So we have all these classifications that you can pick. So I'll just pick this. We can just pick road, paved concrete for now, and we can always change this to whatever we need to. So then I'll come down, and out, and this. So now that we kind of have the general shape of what we of our typical section, we can, or what I would do is come to this first hinge point, and I'm going to add constraints horizontally, and it's going to be to the center line, and we'll keep it at 12 for now. And this can always change dynamically, so this doesn't always have to be this dimension. So this can always be changed to whatever dimension we want it to be, and I can show you how that works later. So we can hit apply, and then we see that this yellow comes up because we have we constrained it once. And then now if we add another constraint and we use slope, then we can select the center line and then say that we want this at, right? So now this hinge point it gets updated. It's 2%. So we can go to this point here, the bottom point, and we can, so I usually don't like to put feature definitions on the points that are not going to be on the top surface, and that's just a preference that I like to use. You don't have to, I guess, but it just makes it easier when you are annotating the cross sections. So I took that off, and we can do a horizontal constraint, and now I'm going to do a horizontal constraint to the hinge, which is the top of our driving surface. So, and here it's going to be 0. I'm going to do a vertical constraint to the same point, and this is going to be our thickness. This is going to be the depth of our structure. So in this case, it's going to be 11 inches. And you can also do, I don't know if you noticed what I did there, but I actually typed in 11 divided by 12, and it knows, well, the software can calculate it for you. So if you need to do some kind of weird dimension, then you can do that. So we can go 11 to 12. And then, so one thing here is in our cross section, or in our template. So I only made points for the top, the bottom, this point, and this point, but I'm gonna add one for this shoulder line here. And then, so let me show you how to add a point if you somehow forget to put one in. So to do that is you just hover the component and you insert, come down here and insert point. And now you have a point that you can use and manipulate. So this point here is going to be our edge of, this is going to be the edge of pavement. So we're going to add a feature definition, and this is going to be, we'll do road edge of pavement, hit apply, and then we'll do horizontal constraint to the hinge, and it's going to be 12 as well. And here's where I'm going to show you how to do the vector offset command, and I'll do it, and then I'll show you why I do it. So what the vector offset does is it's saying, or it gets the slope between points, and then you can give it an offset from that plane. So I usually just use 0 for my offset, but I've seen to where people actually give it some depth, sort of offset a certain dimension below for when they're doing like pavement sections. So I'll demonstrate this, and we can look more into this. So this first parent, I'm going to click the center line, and the second is going to be this hinge, and then I'm going to make sure this is 0. So I'm going to show you now what this does. So if I come here to the hinge and I change this slope to 5, then if you see, and also a cool tip to use is if you hold shift and scroll down and up, then you can see it vertically exaggerated, so we can so you can have a better feel of what's happening. But if I change this value again back to 2, then you see that the slope between hinge and hinge 4 are the same between the center line and this hinge. So that's mainly why I use the vector offset. So then once you apply super elevations to your alignment, then everything will get updated and everything will look how it's supposed to be. So I'm going to do the same thing for the, actually let's change this. We can say this will be, this is technically the edge of pavement 2, changing the feature definitions. We can say EOP1, hit apply. And if you don't hit apply, then it won't save it. So that's a, so just make sure that any change that you want to keep, then you hit apply. So then I'll come to this hinge, then we'll say EOP2. And then I'll come to this next point, which is going to be the shoulder. Have a 6-foot shoulder. So look at your feature definitions and road shoulder. So then shoulder. So I'm going to do a horizontal offset from this edge of pavement, and we have a 6-foot. If I apply, then that'll move 6 feet. Then I'm going to do the vector offset and do exactly what I did for that other point. I'll make sure this is 0. And now, anytime this slope changes, they both will update. So if I go back and change this to what it needs to be for now. So then we have a, if you can see in this section, there's a 5-to-1 3-foot taper that we can, that's next. And that's this hinge 2 here. So we'll give it a horizontal of 3 feet from the shoulder, 3 feet. Then we'll give it a slope, and we'll say from here, and then we'll say. So yeah, be aware of this too. So when you're typing percents, make sure to give the decimal, because if not, then it'll end up like what you just saw. So then now what I'm going to do is I'm actually going to add points here at this edge of pavement and at the shoulder, so we can have the depth throughout, have the correct depth throughout. Because if you can see this taper, let me see, what is this? Yeah, that's the correct dimension. But if you can see that this isn't like, something doesn't look right here. So I'm going to add points, intermediate points under the edge of pavement and under the shoulder, and so we can make sure that everything's looking right. So I'm going to insert a point, insert another point, and okay, so I'm going to show you something that's really cool, and it's really advanced. So if you have any questions, you can rewatch the video, or you can send me questions. So what I want to do is, or what I'm going to do is, I'm gonna tell the software to vertically constrain from this edge of pavement, right? But if you notice, there's this equal sign here. And what this equal means is when I click it, then I can give, or I can extract a horizontal or vertical difference between the points that are in my template to where I don't need to input a value. So in this case, I want the depth of this hinge to be the same depth as the EOP1. So that's exactly what I'm going to do. I'm going to say I want the vertical difference from this point to this point. And be careful here too, because this is the value. But we can always, so if we were to, actually let's see what happens, and then I'll see why I'll show you why why you should be aware of this. So if I hit OK, then I hit apply, then you see how it goes above. But they gave us a multiplier here, which is really cool. So we can just hit negative, and then if you saw, this value changed. If we change it, then it changes back. You can even do any other numbers that you want, so it's pretty cool. So I'll do -1 since we want this point to be below our EOP2. So click OK, hit apply, and now we will finish this off by doing a horizontal constraint to from the edge of pavement 2, and then we'll say 0. We'll hit apply. So now this is so now if I change this dimension, anything that I change this to, value is also going to update. So it's really cool and really helpful to where you don't need to go into each point and change every dimension that you have. And that's the key. That's the key, and that's what I like to do when I'm working with these templates. Is I want to do the least manual edits as possible. I want the software to think for me, at least when it comes to manually inputting values. So I can do the same thing here. I'll do vertical. It's going to be from the shoulder, and then I'll hit the equals. I'll do vertical difference. There's your pavement 1 inch. Hit apply to make sure that stays. And
Hey Trey,
Yes.
Rafael, you can have these broken down by each layer of materials that we're using on the project, correct?
Yes.
Right.
Yes.
So you can have, say, HMAC, then flex base, then cement treated, whatever it is, and that can actually help you get your quantities straight
Right.
up.
Right.
Okay.
Exactly.
Yeah.
Exactly.
Okay. Yeah, I just wanted to indicate that just in case.
Yeah, no, that's exactly right. So, so you can, as long as you can build it in here, and so let's say we had some kind of layer on top that we wanted. As long as you can build it, and it has constraints, then, and it has some kind of volume and depth to it, then we can extract quantities. We can change this to whichever feature definition that or it needs to be, and then once we run the quantity report, then it's going to give us the quantities throughout the corridor. It's just a matter of you drawing the typical section correctly in your template. That's really the main thing. As long as you have a shape in the template and your templates, and you have a corridor going from your horizontal and vertical geometry, then it's going to work. You can get quantities, earthwork, and everything, annotated cross sections and everything. So this looks kind of weird here. I'm just gonna, for now, I'll just do a vector offset from these bottom points. And this can be changed later. So another topic that I can go over quickly now, and then go over more at the beginning of next session, is end conditions. So what end conditions are, it's basically how your model ties in with the existing ground. And I'm gonna do something quick, and I'll explain it as I go, but we'll definitely cover this at the beginning of next session. So I'm going to create a berm, and then we'll add some end conditions to that. So I'll do a constrained component here, and let's find it. I'll use this grade grass. So then I'm going to create some kind of berm here. We'll say it's like 4 foot or something. And another thing to be aware of is, if you don't want your component to be a filled shape, if you want it to be just a line, then you undo the closed shape. The closed shape check. Make sure it's unchecked, and then that will be okay. Oh. So I actually canceled out of that command, so let me do that again. So it's not a closed shape, so then I'll left click and then hit finish to make sure that it finishes. And I'll give it the, let's do 4 foot horizontally, and then I'll do vector offset from these. So end conditions. If you do add new component, we can do end condition. So what this does is this is going to target the existing ground. So I'm going to do just a simple cut and fill slope, or 2 slopes. One of them is cut and one of them is fill. So I'll start at my hinge here. And when you're starting to draw a component, if you hover another point and it becomes white, then that means the points are going to be merged, and it's just going to be whatever was there. Whatever the point name that was there, that's what it's going to be. So in that case, I'll hover this, because that's how I want it to be. I want to merge the points there. And then I'll come up. This is going to be our cut slope. I'll do finish. So when you create an end condition, you get kind of the same dialog as the point properties, but it gives you some extra properties here for the end condition. And I usually always have check for interception and place pointed interception checked, and then we can talk about what this means in the next session. So I'll just say I want 4 to 1 here, and I'll just say 10 feet. And then I'll do the same thing for, just say, cut slope. And then I'm going to do add new component, end condition. I'm going to start here again, and then I'm going to go down, so this will be our fill slope. I'll do the same. I'll do 4 to 1. And then I'm actually going to do I'll just do the horizontal constraint equal to this cut. So then I'll go, and then so to test your end conditions, you see this test in the bottom right hand corner, and if you click on it, then we can see that here are the end conditions that we made, and what the white line and what my cursor is mimicking is the existing terrain. So this is how it's going to tie into the existing terrain, and we're definitely going to go over end conditions more in the next session. But let me show you something cool and create the full typical section really quick right now, and then I can apply it and we can see it in 3D. So if you do new, so I'm going to do new template, and we'll just have it at new template for now. So now I'm in this template, right? But if I were to click this US 67 and I drag it, then you see how it comes in, and then if I right click, then I have the option to mirror or reflect it. So in this case, I'm going to mirror it, and then so now we have the template that we just made, and now we don't have to make it twice. We can just make it once and then come here, and now we have our typical section project. So now that we have it, I'm going to save the template, make sure to always save it, and I'm going to confirm that we have that the active terrain is that the terrain is active, and then I'll come here, I'll click on it, click on the horizontal alignment, create a corridor. I'm going to reset, which means right click, because I want to use the active profile. And what just happened? Oh, there it goes. So now you're going to get this, as soon as you make a corridor, it automatically takes you to the create template drop command. So that's what happened here. And I'm only going to create the template in a small section so it can process and we can see it quickly. So I'm going to click through because this is the template that we just made. If you hit Alt C, then you can see our template library and the points and the template that we just made. So this is the one that I want to use. I'll click, and then it'll ask me what station I want it to be, and I'll just do from 900 to 925. And the drop interval, I like to use 20, and we can talk more about that in the next session. Then we change this to whatever description it is, and we click through all these prompts, and now we can see that we have our corridor here, and we see that it's tying into existing with our end conditions that we made. And if this is just the plan view, so if we were to open up another view and come to the 3D view, I like to use the display style ignore lighting illustration, ignore lighting. So if we click on that, then now we can see the template and 3D model of the corridor that we just made. Then we can also go through how to see cross sections and everything. The dynamic cross sections. So I think we can stop. We can stop for now, and we can continue with in conditions and can do point controls and all that cool fun stuff in the next session. But for now, I think this is a good stopping point.
Trey, I just want to say on behalf of the district, thank you again. I really like the fact that you're really going through everything. You're showing us how we can apply this to different projects and everything, and I'm sure everybody else is going to benefit from this. So, I want to thank you for that. And at the moment, I don't have questions, but I'm sure once I start going through it again through YouTube, I will. So I look forward to that link.
Yeah, no problem.
Hey, this is Sheetal. I'm sorry, I just joined at the very tail end of this meeting, but I got a question on the corridor that you create. When you create the template, you created based on the center line, or I mean the offset that you gave that template. Did you give that the slope, or it just matching the existing um, line at that widening that you're proposing? I don't know if you
So
understand what I'm trying to say, but
okay, so let me share my screen again, then we can look through it. So which point are you talking about?
yeah. So EOP1,
Uh
did
huh.
you that is a smart point, right? So it's gonna pick up the elevation at that point, and then it will apply the slope from that point, or is it that is in reference to the center line?
Oh, so for this template, this is reference to the center line, but we can we can have it different ways. I mean, you can have it to where it'll find the existing ground where this 12-foot offset is, and you can have that be your control for this side, and have the same thing for the other side. It just really depends on what exactly you want to do. But in this case, it it is referencing a 12-foot offset from the center line. But we can make this. What I'll show you in the next session is you can have a parametric constraint, which what this label means here, and we can
Okay.
change it throughout the corridor. We can, so it doesn't always have to be 12. This is just like
Okay.
it's like a default.
Okay.
But I can show you some cool things to where it'll be easy to just draw some line work in the plan, and then your model will just follow it.
Okay. The question I ask is because when you widen, right, not necessarily will have the 2% slope at every 20 feet interval, or I mean, it varies.
Right.
And you will have less than or more than, and
Hmm.
then you will be in that um, place where you are not, now you are not matching with what's existing out there.
Right.
Um, so that's the trouble that I am having with one of our project, and I was
Oh,
just wondering if there is a way to do it. Um,
there
but we can
there is
talk
a way.
about it later. I don't want to take up a lot of your time, but
Yeah, we can. If you want to set up a call, then we can talk about it because I did exactly what you're talking about on another project.
okay.
So yeah, and that project went pretty smoothly, I think.
Is that your US 54,
What
or
was
was
that?
it in different district? Was it in different district, or was it here in El Paso?
No, it was El Paso. It was
Was it US 54?
no, no.
Okay.
But if you set up a call, then I can show you how I set that up. And
Okay. Oh, that would be very helpful. I won't take up a lot of your time. I mean, it will be really helpful if you can walk us through that process. Because what I'm trying to do is adding some level ups, and we know that the slope varies so much, like it varies from 1 to almost 3 in between. So in coming up that level of quantity, I mean, how do you correct the slope with overlay? That's something that I'm trying to find out by creating this corridor. Is there a
Right.
way to do it?
Yeah, I think so. I think so.
Okay, okay. I'll set up a call maybe next week, and we'll go over. And if I mean, if everybody's available, they can listen into it what we're talking about. So it's a good learning opportunity for us, trying to fix something with an overlay and finding it's a quite a bit of effort that would required. So
Right.
yeah,
Okay,
okay,
that sounds good. Okay.
Hey
okay.
Trey, why don't we set up that to be the first portion of next session on Monday?
Okay.
So all the district staff can benefit from that, because I think a lot of they do a lot of those type of projects, you know.
Mm-hmm.
So I think that would be very beneficial.
I agree. You're right. It's on Monday. I didn't even realize. So I think we can start with this one, and then we'll go from there.
Okay, that sounds good.
Okay.
All right.
All right. Thank you.
Good deal. Any other questions, anyone? Okay, so next week we got Monday, I think it's in the afternoon, and Thursday, I think it's about this same time. On those two sessions, Trey, you're basically gonna be on your own here, because I'm gonna be out next